Section 13.4, evaluate inverse trig functions. What we're going to do is, see, I just did this and I did it on mute. So this is a second chance. So here we go. Now hopefully you can hear me. All right. When we're evaluating inverse functions, an inverse function, just like with an inverse of anything else, is undoing something. So an inverse function is undoing that function. So it's saying at what angle is the sine this. All right. So now the trick though is, if I say at what angle is the sine 1/2, I can say, well, the sine is 1/2 here, but you might say, oh, well, the sine is 1/2 here, and we would both be right. So what we do when we figure the inverse trig functions, we limit the domain so that we're talking about the same angle. All right, so we limit the domain of the sine to the first and fourth quadrants because that's where they're going to be different. You're going to have a positive and a negative, and so we have both. Whereas if you did the first and second, they would be the same, and we wouldn't know which one we're talking about. Now, when we do that, though, we give the answers in relation to negative 90 to 90 or negative pi over 2 to pi over 2. So it's almost like we measure either up or down from the x-axis, okay? So that's a little bit different than just choosing the number that's on the unit circle. You're going to go from negative 90 to positive 90, that direction. With cosine, we use quadrants 1 and 2, so it's just from 0 to 180, or the from 0 to pi, using those exact measurements that are on the unit circle. With tangent, we use the same quadrants and the way of measuring as we did with sine. So you're going to go from negative 90 to positive 90, or negative pi over 2 to positive pi over 2. All right, so let's use the unit circle now, and let's look at some of these. If I want the inverse sine, so this little -1 means inverse sine. The inverse sine of -1, what I'm saying is, where is the sine equal to -1? At what measurement? And in the homework, I'll ask you for the degree measurements, the angle measurements in degrees and in radians. So you'll need 2 answers for each of these. So we look, and remember we're looking at the first and fourth quadrants, and the sine is -1 down here at 270 degrees, but remember we're not going to use 270. We're going to say, well, it's 90 degrees downward, so this was negative 90 degrees. And it's going to be exactly opposite of this pi over 2, so it's going to be negative pi over 2. All right? Easy enough? So the inverse cosine of negative square root of 2 over 2 is going to be, well, the cosine, remember, we're looking at the first 2 quadrants. And where is the cosine negative square root of 2 over 2? Well, that's where the x is negative square root of 2 over 2, right there. So we're going to put down exactly what we see, either 135 degrees or 3 pi over 4. All right. Inverse tangent, tangent and cotangent, remember, a little bit trickier because we see the sine and cosine, but with tangent we've got to divide it and find it. All right, so if you remember that tangent is sine over cosine, all right, and so the sine over cosine is going to be, and what I would do is change this back because you don't have anything that's square root of 3 over 3 on your unit circle. So let's go back. Before it was rationalized, it was 1 over square root of 3. So what we're looking for is, if I take the sine divided by the cosine, I want 1 over the square root of 3. So we know that it's positive, so we first decide, well, the tangent is positive in this quadrant, so we're going to look in this quadrant for something that's going to end up being 1 over the square root of 3. So we've got square roots of 3 here and square roots of 3 here. Cosine is where we want the square root of 3, so we want it right here. And then if we check and we say sine is 1/2 over cosine is square root of 3 over 2, flip and multiply, we do have 1 over square root of 3. So that says that this is the angle that I want. So the inverse tangent is 30 degrees or pi over 6. All right, once you find it, that's your answer and you're done. So the whole point was to find what angle measure gave me this answer. Okay, so you're just going backwards. Now, some of those aren't on your unit circle. So if I say, I want you to find theta if the cosine of theta is 3/4. Well, you can say, well, that's easy. All I want, that just means I want the inverse cosine of 3/4, right? If theta is 3/4, then to find cosine, or to find theta, I'm just going backwards, right? So I want the inverse cosine of 3/4, but I look at my circle and there is no 3/4. So if it's not on your unit circle, then you have a cute little button on your calculator, which you've probably already figured out. Make sure on these that you do not use your calculator. Please use your unit circle, all right? And I will know because I won't see the pies and I will know. Okay, here we go. So what you're going to do is simply push your buttons. You're going to have second and then cosine. That's the inverse cosine. And if you'll look right above your cosine button, it says cosine -1, which means inverse cosine. So the second button and then your cosine button, and then it'll give you parentheses, and you just put 3 divided by 4, and that should give you 41.4 degrees. Now, what we're given here is we're given a domain. I want the angle. Now remember that we said you can have, there's more than one place on the unit circle where the cosine is going to be positive. All right. So I want the place where the cosine is 3/4 that's between 270 and 360. So looking at your graph, 270 is here, 360 is here. So we want the cosine in the 4th quadrant, and 41.4 is not in the 4th quadrant. So what I want is using the reference angle. If I'm using the reference angle, I want 41.4 downward, right? So I want 41.4 here. So using that reference angle, remember, we can take this whole circle. We can take the whole circle, because this is the angle we want from all the way from here to here. So if we take the whole circle and subtract the 41.4 off, the whole circle, remember, is 360 degrees, and let's subtract 41.4, and that gives us 318.6. which is between 270 degrees and 360 degrees. So once you find your trig function, your inverse trig function, you need to determine, is this the answer they want, or do they want the, do I need to use this as a reference angle to find the actual theta? All right. Let's see. Oh, one more thing. I have a note to myself just so that I remember. Make sure when you start using your calculator to figure these trig functions, make sure that you look to see, are they asking for degree measure, or do they want this between 4 pi over 3, 3 pi over 2 and 2 pi? Do they want it in the radian degree measurements or the degree measurements? Radian measurements. So make sure that your calculator matches that. All right. You'll have to change between the two modes, and you're going to be doing that quite often. So make sure you become familiar with how to do that. All right. Once you've done that, we're going to move one baby step more difficult and say, if I give you this picture and I want the measure of theta, how do I find it? I want the measure of this degree, or this angle. I want to, I know the two legs, and if I know the two legs, that's going to be tangent, right? We don't know the hypotenuse, which is what sine and cosine use. But I know the tangent of theta is going to be 17 over 6 because it's opposite over adjacent. And so if I take the inverse tangent of 17 over 6, I should get theta. So this is really, really simple. All you do is second tangent 17 divided by 6, and you end up with 70.6, and you don't even have to worry about a, excuse me, a reference angle, because you know you want that 70-degree angle. You want just an acute angle, and you're done. That's it. So last thing, one more you know we couldn't do without a word problem. Here we go. This word problem actually is really simple. If a 52-foot building casts a shadow 23 feet long, what is the angle of elevation to the sun? So all we've got here is we have exactly this problem, except that you have to draw your own triangle. All right. So let's draw the triangle. We've got a 52-foot building, so 52 foot high, and it casts a shadow 23 feet. So the shadow is along the ground and it's 23 feet. And I want to know the angle of elevation to the sun. So here's your theta. Easy sneezy. This is almost identical to this problem because, look, again, we have two legs. We don't have a hypotenuse, so we have tangent again. So we want the inverse tangent of the opposite over the adjacent, so 52 over 23. Plug that into your calculator, inverse tangent, 52 divided by 23. You should end up with 66 degrees. That's it, you're done. All right, so make sure that your calculator is in the correct measurements, either degrees or radians, depending on what answer is called for. And then make sure that you are using the correct quadrants in your unit circle when you do those without your calculator. Good luck.